My name is Aravind. I've just finished my BTech in Metallurgical and Materials Engineering from IIT Madras, and I was lucky to be associated with Professor Tiju Thomas's group, which is Anen, for the last 2 years of my bachelor's. And I did my BTech project also under Dr. Tiju Thomas, and I had a wonderful experience with him and also the other members of the group. So I first met Dr. Thomas around 4 years ago in the first year of my time in IIT Madras, and this was during a innovation fair at the Center for Innovation, which is a student-run lab at IIT Madras. And Dr. Tiju is always very interested in knowing about different kinds of innovation and how they can move forward the potential applications in industry. And he's a regular visitor to the C5 open house. And I was presenting a project about sanitation and toilets, which is one of his interest areas. And we got talking. And he had some really interesting inputs for us in our project. I next met him when I took a course under him. So it was called Advanced Materials and Processes in my fourth semester. Unfortunately, that course is no longer offered, but again, I really enjoyed that course because he basically taught us to think completely out of the box. It's a one of a kind course which has no fixed boundaries, but you learn so much at the end of the course. So following that, I also had some discussions with him regarding some of the grand challenges which we're both interested in, like energy, sanitation, waste management, etc. Because I found him to be a great source of knowledge, and he always took me very seriously. Even though I was just a second year BTech student, he always listened patiently to my ideas and offered constructive criticism. In short, he treated me like another adult, which was really great. So at that point, I had this really ambitious plan of making aluminum nanotechnology powered self-sustaining toilet. And I know that sounds really crazy, but I was powered by youthful exuberance, and Dr. Thomas was even though it was a really ambitious idea, he was always ready to give me his full backing. And with his help, I was actually able to apply for a research grant from the Tamil Nadu Science and Technology Corporation to actually pursue this goal further. And we also won a grant from Nirman, which is the pre-incubation cell of IIT Madras, to actually develop this idea of this nanotechnology powered toilet. Ultimately, those plans didn't come to fruition because, as I said, it was quite ambitious, but there was a lot of learning involved in the way. And to that end, I thought, why not try and do this using simulations on the computer first to see whether our idea works, and then based on the data generated, we can actually pitch in a better way and prepare ourselves to make this product in a far more rigorous manner. So the topic which I eventually started working on at the end of my sixth semester was related to a field known as plasmonics. So plasmonics is essentially deals with the interaction of small metallic nanoparticles of the order of a nanometer scale, which is around 1 millionth of the size of a human hair, and how those metallic nanoparticles respond to light. So as you may know, metals have a lot of free electrons, and these free electrons are not stationary, they tend to move around. And sometimes when the frequency of their oscillations is equal to the frequency of the incident light, very interesting things happen. They can absorb a lot of energy, they can scatter a lot of energy. And this makes these plasmonic nanoparticles very interesting. And so we decided to have a look. So currently the main plasmonic nanoparticles are gold and silver and other noble metals, and obviously those aren't sustainable in the long run, so we need to look at alternate plasmonic materials. And we decided to do materials discovery to find what other materials might be suitable. And we eventually decided to try out a few combinations such as aluminum, core copper shell nanoparticles, which had just been synthesized in the Anen group for the first time. And using software known as COMSOL and a method known as finite element analysis, we were able to prove that these aluminum core copper shell nanoparticles are viable plasmonic alternatives to gold and silver. And we recently published a paper on this in the journal Materials Chemistry and Physics. And this was my first paper this was while I was still an undergrad, so it was quite a big deal for me. And after that, I conducted further research on whether aluminum alloy nanoparticles are also useful, and another paper on that is currently in review. So I really had some great research opportunities and was able to publish and present my work in a lot of ways. So the great thing about working in the Anen lab under Dr. Thomas is that you are the leader of your own project. So that can be both good and bad, because if you're starting afresh and you're quite inexperienced like me, you may not know what to do. But Dr. Tiju and the other PhD students in the lab have always been really helpful, and they answer whatever questions you ask. And Tiju sir is extremely proactive. He conducts regular meetings, and he always keeps popping by the lab to ask on progress, and he's always open to discussions after class. And that really helped me develop my project. So there were some challenges. Like I said, doing it on your own, leading this project on your own, coming up with your own idea is quite difficult. But I think the further you get along, the more independent you become, and you have more comfort dealing with the tools at your disposal. So you get better with time. And so eventually our work has paved the way for alternative plasmonic metals. So in the future, we may not have to rely entirely on gold and silver for plasmonics. So the main applications of plasmonic include light trapping in solar cells. And we have shown that certain aluminum compositions and certain aluminum core shell systems perform actually even better than gold and silver. And this has tremendous implications for the industry, the solar industry, in the coming years. And our work has been patented, and we certainly hope that there will be many industrial applications to come. Another thing which I really enjoyed doing in the lab was being involved in the process of writing research grants. So that is a really important facet of becoming a future researcher, to be able to pitch your work in a way to enable people to fund it. And I really learned a lot while doing it. It does sound quite mundane and boring, but it's actually exhausting, but also extremely fun. So if you're watching this video, you're probably an undergrad who's thinking of venturing into research. And I was in your position just a few years ago. And at least my advice to you would be to give it a shot. You might like it, you might not. There's no secret that research isn't for everybody, but there are some people who really, really enjoy it, because scientific research offers a degree of creative freedom which other disciplines simply don't afford. And material science and nanotechnology is extremely interdisciplinary. It lies at the intersection of physics, chemistry, biology, electrical engineering, and almost any industry you think of has applications for material science products and nanotechnology products. So whatever your interest is, whether it's computational, theoretical, experimental, I'm sure you'll find an avenue for it in the fields of material science and nanotechnology. And finally, as a student, I grew a lot learning from Dr. Tiju and the rest of the lab, the values of teamwork and discussions with people on non-scientific topics like democracy and politics and the future of AI really made me a more well-rounded individual. And Tiju sir has always been there to support me with my references whenever I need them, or any programs for higher studies or fellowships that I applied for. He was always there to help refine my application and also provide the references needed. And to that, I'm very thankful to him and the rest of the group who, despite being many, many years older than me, always treated me in the same way as they treat another PhD student. So I really like that. So, yeah, if you're planning to pursue, if you have even the faintest bit of interest in any of these fields which the Anen group of covers, then I definitely encourage you to try out research at least for one semester, especially through the UGRC and BTP programs. And if you don't enjoy it, you'll still learn a lot of other skills like time management and literature surveys and so on. But if you do enjoy it, there's a whole new world of opportunities waiting for you, and there's no better place than the Anen lab to